Hi guys, I'm just making a quick video about how we can rationalize the denominator when we have surds involved. Now, a couple of you guys have asked this question, so I thought it might be a good idea to make this video. I know we covered it in class, but maybe if we have a focused video going through exactly how to do it, it might be clearer because sometimes in class we have questions, we have side tangents, side missions that we go on. So what does it mean to rationalize the denominator? Now, in simple terms, it means getting rid of surds from the bottom of the fraction, okay? And usually that will mean that the surd ends up on the top, usually, okay? So in this case, we've got a over root b, and what we want is we want our denominator, which is the number on the bottom of the fraction, to not be a surd because surds are not rationals, right? So that's what it means to rationalize the denominator. So there are two different types of examples that you'll face. So these are the ones what we call the easy ones, okay? So easy, but they're still sort of grade 7, so I'll put inverted commas there. So to rationalize simple ones, you multiply the top and the bottom by the surd you are rationalizing, okay? So in this example here, so it says rationalize 5 over 2 root 15. Now, the surd in this question is root 15, okay? So what we're going to do is we are going to multiply the top and bottom by root 15, okay? So we're going to multiply top and the bottom by root 15. Now, first of all, the reason why we can do this is because this here is just 1, okay? So a number over itself is just 1. So we're not actually changing the number, we're just sort of scaling it. And why are we choosing this? Well, you guys should remember that if you have root a times by root a, you always end up with whatever's underneath the root. So it's going to be a. Okay, and if we choose some numbers, for example, if I choose root 49 times root 49, that is going to be 49. And the evidence for that, if we were to work out what root 49 is, it's 7 times 7, and that is 49. Okay, so the number right underneath the root symbol, if you were to multiply it by itself twice, obviously you're going to get whatever's underneath, right? So that there should be quite straightforward and self-explanatory. So now what we're going to do is we're going to multiply this like we would with a fraction. So what's 5 times root 15? Well, that's just 5 root 15. And what is 2 root 15 times root 15? Well, think of it like this, okay? Because you're just doing 2 times root 15 times root 15. And the reason, as I explained before, why we're doing this is to eliminate this surd at the bottom. So root 15 times root 15 is just 15, okay? So if we were to write this out, I mean, I only did that middle step there because just for explanation purposes, but really you'd say, hey, root 15 times root 15 is just 15, times that by 2 is 30. So underneath we'll get 30. Right now, if we want to go ahead and actually simplify this further, we can. So right here, I've just written rationalize, but sometimes it might say rationalize and simplify. Okay, so if we wanted to do that, we could say that actually we can divide the top and bottom by 5. We can cancel out 5 from the top and the bottom. And what do we end up with? Well, 5 obviously divided by 5 is just 1, so it's just going to be root 15, and 30 divided by 5 is going to be 6. So you end up with root 15 over 6. Okay, so these are what we call the easy ones. Now I can show you, we can work through these ones here in the same way. So we've got 6 root 6. So I'm going to times the top and bottom by root 6. What's going to happen? Well, the bottom is just going to turn into 6, and the top is going to be 6 root 6. So this one is 6 root 6 over 6. And guess what? Those 6's, they cancel out. So the answer to this is actually root 6 over 1, but I'm just going to leave it as root 6. This one, well, it looks very similar. It's probably going to be very similar answer to the last one in terms of, you can work out what's going on. So let's just prove it. So 8 times root 8 is 8 root 8. and root 8 times root 8 is 8. And then you can see the 8s are going to cancel out. So you're going to end up with root 8. Okay, here again, we're going to do times root 5 over root 5. So we get 5 root 5 over 5. Again, the 5s cancel out. So you end up with root 5. Okay, so this one is slightly different because you don't have the same number underneath the surd at the top here. So let's be careful. Okay, so we're going to have 1 times root 3 is root 3. And then root 3 times root 3 is just 3. And that's your answer. You can't really simplify that any further. With this one, again, so root 7 over root 7. So that's going to give us root 7 over 7. Okay, again, you can't simplify that any further. So these are the easy examples. Sometimes you might have another number there that you have to consider, but these are like the easiest examples that you could find. Now, you do have like the harder examples. Now, these are the ones that I think everybody is struggling on a little bit. So we're going to talk a little bit of theory as well with these ones. So the harder examples are ones where you've got something like this, where you've got an expression on the bottom, and we've got to get rid of this surd. But if we were to multiply it all by a surd, like if I times this by root 2 over root 2, I'm going to get root 2, and then I'm going to get 2 root 2 plus 2. And it's not helpful. So we have to do something to eliminate the surd from the bottom. So what can we do? Well, those of you who are in year 11 might remember when we went through quadratics, we talked about something called the difference of two squares. Now, if you look here, we've got x squared, and then we've got a squared number next to it, minus 36. Okay, so what would be the solution if we wanted to factorize this? How would you factorize that? What would be your solution? Well, if you know your factorization of quadratics, you'll know that the fourth method we mentioned was difference of two squares. So that just means that you do x plus 6 and x minus 6. So all I've done is just square rooted that and square rooted that, and I put one with a plus and one with a minus. Okay, so in the brackets. Okay, now this is the other way around. So if you have something like this, if we've got 5 minus root 12 and 5 plus root 12, well, actually, if we look at this, we can say, hey, this is definitely the difference of two squares. So what would it be the other way around? Well, that's definitely going to be 25. And then what's root 12 squared? Well, root 12 is just 12. And remember, difference of two squares, you have a minus in between, right? So this is going to be 25 minus 12. Now, you could work this out by doing FOIL, okay, just to prove it. If you want to, you can do that on paper. Do it on paper, and you'll see that you end up getting 25 minus 12, okay? And that is just 13. Now, notice how we had a surd in there, and that surd has become, it's been eliminated, okay? Now, this is exactly the trick that we're going to use on our fraction. Okay, so if you look here, we've got, this is the question, rationalize 1 over 2 plus root 2. So we've got our 1 over 2 plus root 2. So what we have to do is multiply the top and bottom by the same thing, because we can't change the number. So we're just scaling. So it has to be 1. Whatever we're multiplying it by has to be the same on the top and the bottom. But what we're going to use the trick, we know that we could actually look at this, and the other bracket, if we were doing the difference of two squares, what would the other bracket be? Well, it would be 2 minus the square root of 2, okay, and over 2 minus the square root of 2. It has to be the same on the top and bottom. Now, when you do this, what are you doing? You're basically completing the square of not completing the square, so you're doing the difference of two squares. Okay, so look at the bottom, you've got these numbers. So, what do we do? If you have a look at these, you're gonna come to a realization that all you have to do is square this number and square this one and take them away from each other. Okay, so what's 2 squared? Or 2 squared? I'm going to do the bottom first, yeah? The top is easy anyway, so let's do the top actually. So 2 minus root 2, because that times 1 is just that, yeah? Now here, you could obviously do it with brackets, and you could FOIL it. of course, no problem, you can do that. But if you use your brain, you say, hey, that's the difference of two squares. All I have to do is 2 squared, so 2 squared minus root 2 squared. So root 2 squared. Okay, so what is that? Well, 2 minus root 2 is going to be 4 minus 2. Okay, so what is that? Well, that is, again, we'll put the top in, that's just going to be 2. Okay, so you can't simplify this without putting a half in front of this, and we don't want to do that. We'll just leave it like that. It's quite nice. Okay, so you'll see examples like that. Now, if I give you the more complicated one that we did in class, we can go through that again, no problem. It was 2 plus 2 root 2 over, oh, sorry, over 1 minus root 2. So again, you look at the bottom and you say, what do I need to do to complete the square there? Like, not the complete the square, sorry, to have the difference of 2 squares. I keep saying complete the square, the difference of 2 squares. Well, I have to just basically, you're inverting the sign. That's the only thing you're doing. You're multiplying it by the same thing with the inverted sign. Yeah. So we're going to say 1 plus root 2 over, and then sorry, and then here we're going to do the same thing on the top. So 1 plus root 2. Okay, now this one's a little bit more complicated because you've got something more on the top than just 1. Okay, so what we do is, like, think about it like brackets. Yeah, so you're going to do that times by that. Now the bottom is actually very easy. Again, we're just going to square the first one, so we're going to 1 squared minus 2, because root 2 is you know what, I'll do it properly. I'll write it properly. So root 2 squared. Okay, and then on the top we're going to have that. So maybe I'll bring this further down actually, because we can do it properly. So on the bottom we're going to have this. Okay, and on the top we're going to have 2 plus 2 root 2 times by 1 plus root 2. Okay, so the bottom is pretty straightforward, I guess. Yeah, so you know, what are you going to get if you do that? Well, you're going to get 1 squared is 1. 1 minus 2 is minus 1. Okay, so on the bottom we're just going to have minus 1. If you are one of those people who doesn't like doing like shortcuts or that kind of thing, you could actually, on the bottom, you could instead write 1 plus root 2 and 1 minus root 2. Oh, I did it the wrong way around. You could write it like that. 1 minus root 2. You could put that on the bottom instead, and then you can FOIL it out if you really want. But I think that at this stage, you should, if you know what difference of 2 squares is, you should be comfortable enough to sort of use that method. But if you are somebody who wants to do it that way, then that is for sure a way you can do it. Now let's have a look here. Let's FOIL the top. We have to FOIL the top here. Yeah. So if we do 2 times 1, and when I say FOIL, by the way, for those people who are wondering, what the hell is he on about? Well, FOIL means first by first, then the outside ones, then the inside ones, and then the last ones. That's what FOIL is. Okay. It's I saw it on University Challenge a little while ago. I didn't used to use the phrase because I thought it was just made up. I thought, you know, it's just a little trick. But then I saw it on University Challenge, and I thought, oh, this must be official now, so we've got to use it. So 2 times 1. 2 times 1 is 2. Okay, so I'll use black here just to be clear what we're doing. And then 2 times root 2. So that is plus 2 root 2. And then we say 2 root 2 times 1. 2 root 2 times 1 is just 2 root 2. Okay, and then this is the tricky one, right? 2 root 2 times root 2. So 2 root 2 times root 2. Now here you can see there's 2 root 2's next to each other. So they just become 2. So it's just 2 times 2. 2 times 2 is 4. Okay, don't ever feel shy to write it on the side. If you're ever trying to work out what is this, and you want to just do like a little side mission, work it out, and then come back to it. Of course, no problem. As long as it gets you the right answer, there's no shame in it at all. Okay, so once you've done this, look at this and see, hey, what have I got that is similar? Well, on the top there, you've got 2 and a 4. So 2 plus 4 is 6. And you've got 2 root 2 plus 2 root 2. Now, this isn't additional or subtraction of surds. This lesson isn't about that. You should already know how to do that. Nobody asked questions on it. I think everybody was quite good at it in lesson. But you should know that those two added together give you 4 root 2, and then 4 add 2 is just 6. And there you go, right? And then don't forget, underneath you've got a -1. Okay, so what do we do with that -1? Well, if you have -1, then you can just apply it to what you have. So you can flip the signs of everything you've got. So what we can say is I've got -6 minus 4 root 2, and that way I don't have to have it over -1. I can just have it like that. Okay, so that is the answer. And basically the questions that you come across in the homework will all be similar to that. There won't be anything other than that. So have a look through the notes. I'll upload these notes as like a supporting document to this video. And if you have any questions, let me know. And maybe I can going forward, if you have any other questions regarding any particular topic, I'll see if I can make little videos. If I get enough people that want help, then no problem. Okay, thank you.